All right, I'd like to begin the year off with a discussion of all those things that make life on Earth possible. Since biology is the study of life, well, where did life come from? Well, some scientists have some ideas, and there are some things, some parameters, some characteristics, some criteria that make Earth a pretty good place for life. So we're going to be discussing 6 things that make life on Earth possible. There are more than 6 things. This is actually adapted from a National Geographic article from a few years ago that discussed 13 things. I'll link to that in the description. But we're going to be looking at 6 specific things that make life on Earth possible. These things may not exist on many of the other planets found in the universe, in our galaxy, and even in our solar system. And hopefully you'll gain a better understanding of, why life on Earth is such an amazing and wonderful thing. And hopefully you have some inspiration to study it and preserve it and protect it and teach others about it as well. So the first the first criteria, the first of the 6 things that make life on Earth possible is our galactic location is far from hazards. Our location in the Milky Way galaxy is far from all those things that might have snuffed life out early on. So you probably won't see my face for most of this discussion, but I wanted to introduce this one, and I'll introduce all the others. So number 1, in the 6 things that make life on Earth possible, our galactic location is far from hazards. Enjoy. So the solar system is comfortably nestled in a safe harbor between major spiral arms, and its nearly circular orbit helps it avoid the galaxy's perilous inner regions. There are relatively few stars near the sun, reducing risks to Earth from gravitational tugs, gamma-ray bursts, or collapsing stars called supernovae. So, here is our galaxy. This is an artist's rendition. No object made by humans has left our galaxy, let alone objects have barely left our solar system, and they have not left our galaxy. So this is a artist's rendition of the Milky Way based on computer models and imagery collected from space telescopes and things like that. So this is a pretty good approximation of what our galaxy looks like. In case you didn't know, our galaxy is called the Milky Way, and we are right here. And just as this says, we are pretty far from the core. We're far from the center of the galaxy, which is actually a really interesting but dangerous place. It's brighter not because there's a giant star there, but because there are so many stars there. Stars are jam-packed into the core of our galaxy. And actually, they are so jam-packed that there is a supermassive black hole right in the center of our galaxy. So being around all of this debris and all of this dangerous radiation and explosions and black holes would not be suitable for the development of complex life, let alone even simple life. So we're lucky. We are way out here, beyond 20,000 light years, in between 2 spiral arms. So it's a relatively quiet and remote part of our galaxy. Now, quick facts related to what you're seeing here. There are hundreds of billions of stars in our galaxy. There are hundreds of billions of galaxies in the universe. So that's just mind-boggling altogether. And also a light year. So once again, from the core to this point is 10,000 light years. To this point is 20,000 light years. And we're beyond 20,000 light years, closer to 30,000 light years from the center of our galaxy. Now, a light year is a measurement of distance, even though it has the word year in it. It's the distance that light travels in a year. Now, a photon, a particle of light, travels at about 300,000 kilometers per second, or around 190 miles per second, which is really freaking fast. You may know this, but it takes about 8 minutes for light to travel from the sun to the Earth. And I have a short video, short-ish, maybe shorter than this one, short video that I'll link to in this video from Vsauce, which I think is just a lot of fun. It's not required, but it's fun. And it dives into some of these concepts of like the sun and the galaxy and light and things like that. So anyway, we're not near all this dangerous stuff. In fact, we're actually pretty far from stars in our stellar neighborhood. So here's the sun in the center. We have zoomed way in from a picture of the galaxy that represents about 50,000 light years from the center to the outside. So this is a big galaxy. and we're moving in towards our stellar neighborhood and the closest stars to the sun. So here's the sun in the center. We have 5, 10, 15, 20 light years away, and the closest stars to us are this Proxima Centauri and Alpha Centauri A and B. They're a little under 5 light years away, around 4 light years away, and they're the closest stars to our sun, which is actually pretty distant when you think about it. And that's a good thing, because if we had stars moving around closer to the sun, they might actually pull planets out of the sun's orbit and into their own orbit, or they might push planets out of orbit around the sun and off into space. That is possible. So if a star were to move close enough to the sun, it might actually push or pull a planet, most likely Jupiter. But thinking about that might be kind of cool. Maybe there's a good piece of science fiction writing on that. Anyway, that's number 1. So the number 1 is we're in a good spot. We're well placed in our galaxy. So anyway, I look forward to presenting more material to you in the future and seeing you shortly in class.